In this video, we're going to look at multiplying by the number of whatever base number you're in. So we're going to look at these three examples to start with. So what is 53 in decimal by 10 in decimal? So 10 being our base. What is 1001 in binary by 2? That 2 is decimal. And what is AA3 in hexadecimal by 16? So let's just look at the example we can do in our heads and break it down. What is 53 times 10? Well, it's 530. So we look at this. What happens to each number? Well, each number moves across left. We add a 0 to the end, whichever you want to say. So why does this happen? Well, if we break this down, this is 50, the tens, this is 3, the units, and this is by 10 to the minus 1. So that would be 1 over 10, which is a tenth. So this would be 0 tenths. So this is 53.0. If we multiply each of these by 10, using our knowledge of powers of indices, when we have any 10 to a power by 10, and this will be 10 to the 1, you add the powers. So each of these 10s is going to move up 1. So this 10 to the minus 1 becomes 10 to the 0, this 10 to the 0 becomes 10 to the 1, and this 10 to the 1 becomes 10 to the 2, or 10 squared. So each of these shifts left is a nice way to look at it. They move across, not quite adding a 0, but that works just as well. So this number here is 53.0, and this number over here is 530. 0 units, 3 tens, and 500, so 530. So if we extend this into our other number systems, so we have 1001 in binary by 2 in decimal. So in this we just follow the same rule. If you remember, in our binary, our base is 2. So if we were in binary, we'd write 2 decimal as 10. So again, when we multiply by 2, really what we're doing is multiplying by 10. Because if we have 1001 in binary, we multiply that by 10 in binary, everything shifts left, and we get 10010. So we're adding that 0 to the end. Let's take a look at this on the regular computer calculator. So here is my calculator. If I click View and go to Programmer, it pops up here. So I get over here my number systems. So the long-winded way we could do of this is we could type 1001 in binary. 1001, that's in binary. We can convert that to decimal. We could do it the long way, but this will do it for us, and that's 9. Then we can multiply it by 2, all in decimal. That will bring us to 18. And then we can convert it back to binary, and you see we get the answer here. So we have 10010. So this shows that it's correct. Again, 2 in binary, 2 in decimal, you would write as 10 in binary. So you got this one here. As we move on to our last example, we have AA3 in hexadecimal by 16 in decimal. So again, this is just going to cause it to shift left, because 16 in decimal is 10 in hex. So what we get here is AA3 by 10, which is AA30. Again, to check that in the calculator, clear the screen, move into the hex. So I get AA3, type it on the keyboard, convert that to decimal, multiply it by 16. So that's in decimal, then convert it back to hex. So this shows that it's correct. You could do that conversion, but you'd save yourself a lot of work doing it this way. So when you multiply by base, you're just going to shift everything left. So let's extend this on now a little bit and look at a couple more examples. So what if we had to multiply 1011 times 4, or 1000 times 8, and 1111 by 32. Again, these are binary, and then these are decimals. So again, we break this down. We think about our place values. So we have 2 to the 0, 1, 2, 3, 4, 5. These will correspond to these figures here. So 4 would be the second place. So that would be similar to 10. 8 is the third place. So that will be similar to 1,000. And 32 is the fifth place. So that will be similar to 100,000. So if you multiply by 32 in binary, that's just like multiplying by 100,000 in decimal. So we can look at the examples down here. 1011 binary times 4 in decimal. We can convert this both into binary here. So we'd add 2 zeros to the number at the end. For 8, which is our third place, that will be 1,000 in binary. So we put 3 zeros at the end. And for 32, we have 1111 times 100,000, and we add in the 5 zeros onto the end. So when we multiply by 32 in binary, it's like multiplying by 100,000. We'll add 5 zeros to the end of the number. Finally, we can carry out multiplications in hexadecimal. So what is 11 times 16? What is ABCD times 256? And what is 5E times 4096? So using the same thing as above, 16 in decimal will be equal to or equivalent, the symbol for equivalent to 10 in hex. 256, well that's 16 squared, so that's the third place, so that will be 100, and 4096, that's 16 cubed, so that will be the fourth place again, 16 to the 0, 16 to the 1, 16 to the 2, 16 to the 3, so that will be equivalent to adding 3 zeros onto the end. So if we take these examples, we have 11 by 16, which is 10 in hex, so we have 110, ABCD by 256, well that's by 16 squared, so that's 100, so that's ABCD with 2 zeros at the end. And finally we take 5E by 496, 496 is 16 cubed, so that is 1000, so we take 5E and we add 3 zeros to the end. Again, let's take a quick look at this on our calculator. If we go to hex, we have 5E, so we could convert that to decimal, which would be 94. We could convert it, multiply it as they asked us by 4096. So in decimal, that's what this is. Then we convert that back into hex, and we would have, just like we have here, 5E and 3 zeros. So that is your breakdown of how you multiply by your base. So that's a shortcut, and again, it's effectively adding zeros. So figure out how many zeros it should be and pop them at the end.